Can everyone hear me? Okay, thanks for your patience. While I was preparing these slides, I wasn't quite sure how to introduce myself because I just passed my dissertation defense a few weeks ago. Thank you. So I don't have the diploma in hand. I don't know if I can officially say doctor, but at any rate, I can. I am Dr. Emmanuel Bello-Ogunu, and I'm from UNC Charlotte in North Carolina, USA. And I'd like to talk to you about crowdsourcing for context regarding privacy within using Bluetooth beacons in an indoor setting. So quickly, before I jump into it, quick show of hands. Can I see who has heard of beacons, who has used them, interacted with them? Okay, very good, more than expected. I know who to avoid when the hard questions come. So I'm just going to give a brief overview of beacons so that everyone is on the same page before diving into my contribution. So Bluetooth Low Energy beacons are small, low power, low cost transmitters that continuously send a low energy beacon signal, Bluetooth signal, So unlike traditional Bluetooth or the Bluetooth below 4.0 that most people are aware of, there's no syncing, there's no pairing required. This sensor simply sends out a signal continuously, and any device that comes within range can pick up that signal and trigger some sort of action or notification. So in action, these beacons act as proximity sensors. So imagine you're in a supermarket or a shopping mall, and you walk by a section of the store, and instantly you get a notification for a product that you just walked by, and you just received a coupon for that product. So this interaction is using these beacons. However, you do have to have an application on your device that can appropriately handle that signal. Otherwise, nothing will happen. And obviously, Bluetooth does have to be on. So as far as the kind of information that you get from these encounters, the idea of the beacon is what is being transmitted. And that's stored somewhere in the cloud, so that when that application on the device discovers that signal, then it will check the cloud in order to determine who owns the beacon, what kind of items might be nearby it or associated with it, as well as the proximity of the user. So the kind of pieces of information that mark an encounter include the time you were there, the duration, the frequency of visits, even the travel path, the specific path you took within a space that's equipped with beacons. So a lot of this provides a wealth of information to the beacon providers, to the retailers, especially from an analytics perspective. You can also know precisely where someone is indoors. But on the flip side, users, due to the seamlessness of the technology, aren't even aware of how it's working, when it's being used, and what information about themselves is being shared. And so I argue that there needs to be some sort of middle ground. Not everyone would be comfortable with sharing their location every single time they're shopping. And yet some might be, depending on where they are, what items are nearby. And so that's the issue. There's no real context for people to make a proper decision when they encounter these Bluetooth beacons. And we do know from research that contextual integrity is important to the privacy perceptions associated with technology. So in other words, context matters if I'm going to decide when and where and with whom I'm going to share certain information. So one possible solution is to have the beacon providers or the retailers come up with labels. Some way to say, okay, beacon A is associated with shoes, beacon B is associated with t-shirts, etc. And then maybe also indicate this is a sensitive beacon. A lot of people may not want to share information with this because it's sensitive. But the issue with this is that, first of all, it's hard to expect all the beacon providers or all the retailers to abide by some standard where they provide these categorizations. And secondly, the notion of privacy that these beacon providers would have would likely differ from ordinary users. Naturally, they're going to want to collect as much information as possible, so they would be less inclined to be or to consider any beacon sensitive as an ordinary user might. So instead, I posit that we turn to the users themselves in order to determine what is sensitive and when and where am I willing to share. And so in doing so, I posit that crowdsourcing can leverage users to contribute beacon labels and therefore allow them to make informed privacy decisions. Crowdsourcing can just be defined as ordinary people coming together and collaborating to contribute to a body of knowledge, or perhaps to solve a problem, Typical examples include Amazon Mechanical Turk. I'm sure many of you have experienced that or are familiar with that. Wikipedia is a website where, again, a lot of people come together and contribute information. Similarly, any crowdfunding sites that you may have heard of, GoFundMe, Kickstarter, these are all examples of crowdsourcing. So I believe that through crowdsourcing, we can allow users to come up with these privacy labels so that people who have discovered beacons before can now help inform other users who are encountering them for the first time. So I came up with a user study in which I wanted to demonstrate a crowdsourcing-based approach to introducing context to beacon encounters. My hypothesis here was that crowdsourcing is an accurate and efficient approach to providing users with context during these beacon encounters. So for this study, I recruited 90 participants from my college campus. I structured this as a between subjects design and marketed the application as a scavenger hunt. And so I had people within this 3-week span use my application in a game sort of format to walk around our bookstore and to label 9 of these beacons with a category label and a privacy label. The reward for participating was a $5 Starbucks gift card. And the measures that I was interested in studying include the label accuracy, the label time, and the actual location sharing that they indicated they'd be willing to do or not do. This is just a brief map of our bookstore, our floor plan, along with the locations of the beacons. So I chose ones that I felt would be varied as far as the type of category and privacy that users would have. So I had the ATM as my ground truth or my benchmark for what a private beacon would be, considering most people would probably not care to share every time they went to an ATM. And on the opposite end of the spectrum, the Starbucks beacon, I considered that the benchmark for the least sensitive or for a public beacon. And so with those two benchmarks, I can now compare the remaining beacons to see how sensitive they may have been according to the users in the study. So these are screenshots of the application that I built using Android. A user would use this application in order to enter the main menu and start a session. And upon doing so, you'd see in the middle screen that they would receive a list of beacons with which they were within proximity, sorted by distance. So selecting any one of these beacons allows you to do 2 things. You can either locate the beacon in a Find Me mode. That third screenshot is a radar that users would see if they needed help locating a beacon. Or if they've spotted it, then they could label the beacon. So the far left screenshot, they could choose from a number of categories in order to say that this beacon is this category. Once a category is selected, then in the middle screen you see a privacy label form that they completed. So users would indicate from low to high how sensitive a beacon might be considered, or in other words, how concerned might they be when it comes to sharing their location at that specific beacon. And then also marking the social circles that they would be willing to share with, which included their friends, Barnes & Noble, our campus bookstore, the university as a whole, or the general public. Lastly, once they had done this for all 9 beacons, they would be presented with their final score. Again, because this was a scavenger hunt game, they received points based on the number of beacons that they labeled, how accurate those labels were, and the amount of time it took them to do so. So I mentioned that this was a between subjects design. So I had 3 different groups that I was looking at. I described them as Top Cat, Crowd Cat, and No Cat. So earlier I mentioned that a plausible solution to providing these labels would be to have the beacon providers or the retailers generate these labels. So the Top Cat group represents that hypothesis, that you could provide a specific label for them, and then they would select that in labeling these beacons. The middle, the Crowd Cat, represents the crowd, the users who saw recommendations for categories based on other users inside of that group. I don't know if you can see, but those 3 that are under most popular, you'll see that Barnes & Noble Women's Apparel had 1 user who marked that as a category label. Under that, Polo Ralph Lauren had 10 users. And then under that, Men's Apparel, 1 user. So you can see, based on the responses from the rest of the users in that crowd group, what the most likely category would be. And then my control group, No Cat, did not receive any kind of recommendation. So again, my goal was to show that the crowd could be relied on to accurately and efficiently generate these labels for beacons within a space. So in order to make this analysis, I performed a one-way ANOVA between the three groups and their respective accuracies. You can see the top cat group had an accuracy of 94%, while the crowd cat had an accuracy of 92.5, and no cat 86.6. So the results of the ANOVA test in the square on the right, you see that we did have a p-value of 0.01, which allowed us to confirm that there is a significant difference in the accuracy between these three groups. In order to find where that difference lies, I did a post-hoc comparison and found that for crowd and no cat, there was a significant difference in accuracy, as well as top cat and no cat. But there was not a significant difference between top cat and crowd cat. So in other words, we can safely say that the crowd can reliably contribute labels that are as accurate or comparable in accuracy with the top cat group, and obviously performing better than the no cat group. Performing a very similar test on the label time, or the amount of time it took users to provide these labels, I first transformed the time, since it's not a bound normal variable. So after doing a logarithmic transformation, I was able to do a one-way ANOVA, and again, found a p-value less than 0.01, confirming that there is a difference in the label time between the three groups. And the results were very similar here. Both the crowd and the top cat group performed better than the group who did not receive any recommendations. But there's not a significant difference between the top cat and the crowd cat group, which is good. That's the result we wanted. We want to be able to say that the crowd can do this just as efficiently as the group that is given the correct label right away. And lastly, I wanted to look at the location sharing responses that users provided through the privacy labels. So this is just an aggregate view of those. If I can draw your attention to a sensitivity column, that is just taking the low to high that users marked for sensitivity of a beacon and translating that to 0 to 100. And then the remaining columns marked with share with, those all represent the percentage of participants who are willing to share their location at that specific beacon for that given social circle. And so again, the first row, ATM, that was our benchmark for the least sensitive beacon, and Starbucks at the very bottom was our benchmark for ATM was the most sensitive, and Starbucks was the least sensitive as far as our beacons. And then comparing all the rest, I did a Cochrane's Q test in order to compare the matched responses, that is, compare the willingness to share with a certain beacon for all 9 beacons. And upon doing so, did post-hoc comparisons within each social circle, so within friends, within bookstore, within university, and within public. I did post-hoc comparisons to see, did the restrooms beacon, for example, were they more likely to share at the restrooms than ATM? If there was a significant difference, then I would mark it accordingly at the table. So there's a lot going on here, but just to summarize, this is all just to show that it does depend on what the beacon is and who has access to that information that participants are willing to share their location at that beacon. So all of this combined, the label time, the accuracy, and their willingness to share, and the differences between who and where they share with, all help us confidently assert that crowdsourcing can be used as a tool to incorporate context when encountering these beacons. And so to conclude, I argue that the rapid growth of beacon applications demands proactive steps to handle location privacy issues. And my objective was to empower users with a tool that allowed them to manage their privacy. In order to manage their privacy, they need to know what is the context in which their location would be shared. So I confirmed that sharing location information during beacon encounters does depend on context. And I implemented a crowdsourcing-based approach to incorporate context during these encounters. So my future work is to integrate this crowdsourcing model into a beacon privacy management framework, something that would allow users to, based on the information received, create privacy policies for any given beacon, where they could say, based on what the crowd is saying, I'd like to set a policy where I don't share my location at this beacon, but I will share it with this beacon. I hope all of that made sense, and I appreciate your attention. Thank you, I appreciate it.